Dear students, today we introduce formally the latest developments in time series econometrics. That is, the development in time series econometrics that has taken place in the last 40 years. As we have discussed in the previous classes, in econometrics we use three types of data: cross-section data, time series data, and a combination of cross-section and time series data, namely panel data. And a classical linear regression model is based on 7 assumptions, which we have discussed in detail. And we have also discussed the violation of these assumptions. If you are using cross-section data, an important assumption is the assumption of homoscedasticity. And as we have seen, in most cases, this assumption will be violated. So we have the problem of heteroscedasticity. We have also discussed if heteroscedasticity is present, what are the remedies, solutions available. Similarly, while discussing time series data, a major problem is the violation of the assumption of no autocorrelation. That is, we will encounter the problem of autocorrelation or serial correlation. And if serial correlation is encountered, we have also discussed what are the solutions. Now, when we consider time series, a problem which we will encounter, and the problem which has received much attention in the last 40 years is the problem of non-stationarity. The problem of non-stationarity, an issue of time series which we have not discussed in detail. Now, an important aspect of econometrics to time series variables in the last 40 years is the development of tools and techniques to assess whether a time series is stochastically trended. Stochastically trended. Stochastically trended is another name of non-stationarity that we will discuss later. So, in the last 40 years, econometricians developed a lot of tools and procedures to assess whether a time series variable is stochastically trended. Now, if you plot most of the time series, such as GNP, NNB, consumption, investment, etc. At least for the developed countries, this time series exhibits what is known as a tendency to increase over time. A tendency to increase over time, but an increase which could not be explained as random deviations from an underlying deterministic trend. Most of the time series in the developed countries exhibits a tendency to increase over time, but an increase which cannot be explained as random deviations from an underlying deterministic trend. Deterministic trend. Rather, the trend itself shows changes. Trend is not remaining constant. Trend itself shows changes. Perhaps a steep increase at one time and a slow increase at other times. What I say is, suppose that you plot GNP of a developed country like USA, plotted against time. You will observe that this GNP increases over time like this, exhibits an increasing trend. And you also know that most of the economic time series increases with cyclical fluctuations characterized by what is known as business cycles. But if you observe this pattern, you will see that we cannot represent this series with a single deterministic trend. Actually, the trend itself is changing. There is one trend here, another here, like that. So the trend itself is stochastic. That is, the deviations cannot be considered as deviations from an underlying deterministic trend. Now it has been known to econometricians that a typical time series is trended. This is clear from plotting a time series. Now consider a pattern like this. A pattern like this. If the pattern is like this, we can say that deviations are from an underlying deterministic trend. The trend is deterministic. You can estimate the trend by giving a deterministic specification. But if the trend itself is stochastic, not remaining constant, a steep increase followed by a less steep increase, etc., then the trend is stochastic. So you cannot estimate the trend by giving a deterministic specification. So the difference is between whether the trend is deterministic or stochastic, and most of the time series exhibits trend. And it was known to econometricians for a long time period that the typical time series is trended. And with a few exceptions, especially Box and Jenkins. Box-Jenkins methodology is known as ARIMA, autoregressive integrated moving average process, that we will discuss and study in detail. So except Box and Jenkins, most of the econometricians considered this issue by giving a deterministic specification. The trend in the series has been considered by giving a deterministic specification. As an example, suppose that you have two series, xt and yt, say consumption and income. Two series, xt and yt. Then a regression of yt on xt is meaningful. And if one series is trended, a regression of yt on xt is meaningful if and only if the other is also trended. For example, if this is the xt series trended and this is yt series, so both the series are trended, then only a regression of yt on xt is meaningful. So a typical reaction to trended series from econometricians was twofold. One, you detrend xt and yt. If you regress xt on time, yt on time, then you will get a detrended series. The residual from that these regressions will give you the detrended series. Then you can regress the detrended yt series on xt series. This is one solution adopted by econometricians. If there is trend, then we use detrended series. There are various procedures available for detrending the series, and we will discuss this in detail later. A second is introduce time as an additional variable, as a dummy variable, taking the values 1, 2, 3, etc. up to n. So the second approach is yt is equal to beta 1 plus beta 2 xt plus beta 3 t plus ut. Trend is introduced as a variable. And remember this specification is based on the assumption that trend is deterministic. Trend like x is deterministic. Then only you can give a deterministic specification to capture this effect. So these were the two approaches to deal with the trended variables. One is you detrend and use detrended series. Second is introduce time as a variable. Both of these approaches are based on the assumption that the trend is deterministic. The trend is deterministic. We will say that the series is trend stationary. If the series is with a deterministic trend, and if the trend is removed, you will get a stationary series. I will explain stationarity in detail later. Such a series is known as trend stationary. Now, no question was raised to this practice up to 1980s, when development in two fronts criticized this traditional practice. One is a seminal article by Nelson and Plosser. Nelson and Plosser, published in 1982. Nelson and Plosser, published in 1982. It is a watershed in the history of time series econometrics. In this paper, they concluded that the picture of time series being generated by deterministic trends is misleading. They concluded that trend is deterministic. The idea that trend is deterministic is misleading. I mean, the trend is like this, deterministic. I will explain the patterns in detail later. If the trend is deterministic, the pattern of the series will be like this. So the trend as deterministic is misleading according to the paper by Nelson and Plosser. Also, the view that trend is deterministic is not satisfactory or is not comfortable at a theoretical level also. In the theoretical level, suppose that there is a shock to the series at some point, a stochastic shock to the series at some point. And if the trend is deterministic, the effect of this shock will be short-lived. The effect of this shock will be short-lived, so that the series will return to the underlying deterministic trend in a short period of time. If a time series is characterized by deterministic trends, and if there is a shock to the series at some point, the effect of the shock is short-lived. Means the series will return to the underlying trend within a short period of time. We will say that the series mean revert. The name mean revert. It will revert to the underlying mean. So a deterministically trended series is characterized by mean reversion. Mean reversion. But in a stochastically trended series, shock has permanent effect. Shock has permanent effect in the sense that, suppose that this is the underlying deterministic series. The series is like this. Suppose that there is a shock here. Then the series will move away from the underlying deterministic trends. It may return to the underlying deterministic trends after so many time periods. That means in a stochastically trended world, shock has permanent effects. We will say that the effect of the shock is integrated into the series. Integrated into the series. So we will say the series is integrated series. Integrated series. Integrated because the effect of the shock is integrated into the series. So stochastically trended is also known as integrated series. Deterministically trended is characterized by mean reversion. And if a series is stochastically trended, we will say that it is non-stationary. Deterministically trended is not stationary, but it is a different type of non-stationarity that also we will discuss. So, stochastically trended, non-stationary, integrated, all are one and the same thing, used to describe the same phenomena. So in a stochastically trended world, shock has permanent effects. The effect of the shock is integrated into the series. Stated differently, in a deterministically trended world, if there is a shock, the effect of the shock will disappear quickly. The series will not remember the shock forever. But in the case of a stochastically trended series, If there is a shock, the series will remember the shock forever. The series will remember the shock forever. So, integrated series. Now, there is a point I want to say about this paper. It is known to you that there are two schools of thought in macroeconomics. One is the classical tradition, the other one is the Keynesian tradition. Classical, neoclassical, then monetarism, neoclassical, real business cycle theory. That is the one tradition. The other one is Keynesian, neo-Keynesian, post-Keynesian, etc. In the classical tradition, an important school is real business cycles. Business cycles, according to this school, is caused by real rather than nominal factors. The most important factor causing business cycles is productivity shock. If there is a productivity shock, then the series move away. Its impact will be felt for a long period of time. And the origin of the real business cycle theory stems from the paper by Nelson and Plosser published in 1982. And to read more about this paper, real business cycle theory, etc. in detail, you read Snowden and Wayne, Macroeconomics, its origin, development and current state by Snowden and Wayne. So this is the first paper, questioning the traditional wisdom of deterministic trends. The second, and remember this, if you plot a series, and if the series exhibits a pattern like this rather than this, then the trend is stochastic, not deterministic. Then you cannot give a deterministic specification to estimate the trend because trend is stochastic. That is one point. While Nelson and Plosser was concerned with the individual series, univariate analysis, in another development, also in the 1980s, two econometricians, Granger and Weiss, and also Angel and Granger. Angel and Granger, published in 1983-1987 in two papers, published in 1983, another in 1987. Angel, Granger and Weiss, Angel and Granger, in two seminal papers, considered how to deal with two or more series, each of which has a stochastic trend, or each of which is integrated. Nelson and Plosser analysis was based on univariate analysis. Actually, Nelson and Plosser analyzed a large number of US time series and concluded that most of the time series is non-stationary, stochastically trended or integrated. Or their conclusion was the null hypothesis that the time series is non-stationary cannot be rejected. We will explain these points later. So, in two papers, Angel and Granger considered how to deal with two or more series which are stochastically trended or what is known as integrated. They introduced the idea that if two or more integrated series which do not have a tendency to move together will be tied together in the long run. Even if two time series are integrated, One time series is something like this. Another time series is something like this. Both are integrated, characterized by stochastic trends, appear to be not related at a first glance, may be tied together in the long run. For example, if a YT and CT, consumption and income, both are integrated non-stationary series, and in principle, they appear to be not related in their stochastic trending, but they may be tied together in the long run. They may be tied together in the long run. That means even if YT and XT are integrated, they are tied together in the long run. That means we say that they are co-integrated. They are co-integrated. Here co means tying together. Co means tying together. In appearance, they are integrated series characterized by stochastic trends, but they are tied together. That is, they are co-integrated. So the idea of co-integration was introduced by Granger and Weiss and Angel and Granger in two seminal papers published in 1983 and another in 1987. So remember, these three papers are very important in the context of time series econometrics. These papers introduced the idea of non-stationarity, that is stochastic trends, as against deterministic trends, that is integrated series, also the idea of co-integration. So, as I discussed in this explanation, when we talk about non-stationarity, non-stationarity does not mean a sustained increase or a sustained decrease. So in this series, so this is a tendency to move upwards, non-stationary, a tendency to move downwards, again non-stationary. But non-stationarity does not mean sustained increase or sustained decrease. Non-stationarity also implies what is known as a sustained walk in one direction before moving into another direction. As an example, if you plot nominal exchange rates, you will see that nominal exchange rates show a tendency to decrease for many time periods, followed by a tendency to increase for many time periods. That is, we will say that there is sustained walk in the downward direction, followed by a sustained walk in the upward direction. This is also a kind of non-stationarity. Non-stationarity does not mean trends. It is not necessary that a series exhibits an upward or downward trend for it to be non-stationary. What is required is only a sustained walk in any direction. That is, if you plot many time series, you will see that most of the time series like GNP, consumption, investment, etc. exhibits an upward trend. When I say upward trend, characterized by stochastic trends, some series also exhibits deterministic trends. That is another issue. The difference will be clear to you when we proceed. Remember this, stochastic trend is what is known as non-stationary or integrated. Deterministic trend means shock has only temporary effects. But you will not get such a sustained increase for all the time series. Say a time series is like this. It is moving like this for many time periods. Then it is moving like this, again like this. This series is not exhibiting any sustained increase or sustained decrease. This series exhibits only a sustained walk in the upward and downward direction. This is also a kind of non-stationarity. We will discuss the differences later. So, a framework is required to explain different types of non-stationarity, and there are two aspects of the stylization of how an economic time series is generated. We have what is known as two aspects of the stylization of how an economic time series is generated. Let us see what are they. We say that realizations there are two aspects of the stylization of how an economic time series are generated. You need not worry whether it is stationary, non-stationary, trended, non-trended. That is a concern we will consider later. For the time being, realization of economic data are viewed as being generated by stochastic process. Stochastic process. Now remember this, in the context of cross-section data, we make a distinction between population and sample. There is a population, sample is generated from the population. In the context of time series, we use the word stochastic process and realization. So stochastic process is akin to population, realization is akin to sample. So instead of using the name sample, we use realization. Instead of population, we use stochastic process. So realizations are generated by stochastic process, and a particular realization, particular sample at a specific time period is, or a specific point is just one of the possible outcomes from an underlying stochastic process that require an explanation. Then only the point will be clear to you. You consider GNP in India, say from 1960 to say 2020. Now, this GNP is a stochastic process. It's a time series. It's a stochastic process. Now, in the year 1960, you observe one value. In 61, you observe one value. So, from 1960 to 2020, 60 observations. And this is a realization. The 60 observations you have obtained in India is 60 realizations, or it is a sample. But it is generated by the stochastic process. Now, what is the stochastic process? Suppose that history is repeated. So, in the year 1960, there will be another observation. If the history is repeated again and again an infinite number of times, in the year 1960 you will generate a lot of GNPs. And in the year 61, 62, etc. That is the stochastic process. That is the stochastic process from which we observe one point. That collection is the samples. That is the difference between stochastic process and realization. We use the name stochastic process for time series and realization for a particular sample, just as we use sample and population. And this point must be remembered always, because for any time series variable in a particular year, month, week, whatever it is, you observe only one point, that is a sample point. But for the same time, you can generate infinite number of observations. And that is the difference between stochastic process and sample. That is the first stylization. The second stylization is realizations from stochastic processes generating economic data show a distinct tendency to sustain movement in one direction. Realizations exhibits a tendency to move in one direction. That means the stochastic process generating the data will not stay still. Realizations generating, stochastic process generating realizations will not stay still. They exhibit a tendency to move in one direction. Sustained move in one direction. What type of a move will be considered later. Now, one more point is, suppose that we know that we use x bar as an estimator of mu. X bar is an estimator of mu if and only if the sample observations are IID. Now, if you have a GNP, one observation for each period from 1960 to 2020, and suppose that you calculate the mean, you will get a value for the mean of the series for the entire time period. Call this x bar and is equal to sigma xt by t. T is a number of time periods. T is equal to 1 to t. Now the question is, can we say that this x bar is an estimator of mu? The answer is no. Because as you can see, if the series exhibits a pattern like this, a sustained move in one direction. Now as you can see, for the year 1960, there is a mean, call it mu1, mu2, so etc. mu(n). And arithmetic mean will not represent any of these means, because if the series exhibits a tendency to increase over time, you will see that mu1 is less than mu2, less than mu3, etc. But if the series is like this, then mu1 is equal to mu2, equal to mu3, and x bar is an estimator of all these mu's. So x bar can be considered as the estimator of mu. So remember this point. We use x bar as an estimator of mu if and only if mu is constant. This is true for a series which is stationary. But for a series which is not stationary, series which exhibits a tendency to increase over time or decrease over time, or a series which exhibits a sustained walk in one direction, then x bar, the mean for the time series from the realization, is not an estimate of mu. We can only say that the sample mean is sigma xt by t. It is not an estimate of mu, the underlying parameter. So remember all these points. Remember this when we discuss time series. The distinction is between whether the series is deterministically trended or stochastically trended. Most of the time series is trended. Trended does not mean that it exhibits an upward move or downward move. A sustained walk in one direction is also a case of trend. And in the last 40 years, from 1980s, a lot of tools and procedures were developed by econometricians to deal with the problems created by stochastic trends. This is what we study under the heading non-stationarity. So in the subsequent classes, our concern is what is non-stationarity, how to deal with the non-stationarity. Then we consider the issue of co-integration and related topics. And the developments in these areas has given rise to a separate branch in econometrics, namely time series econometrics.